Hello. Today we will be discussing the modeling of molecules. As we know in science, we often create models to represent things that we can't see or that are more abstract. For that reason, we use models to represent molecules, which are too small for us to see. As we know from previous lessons, the chemical formulas of a compound show us the type and the number of atoms that are present in a molecule of that compound. However, there are several pieces of information about the compound that the chemical formula alone does not give us. That is why we use models as representations of the compounds. The models give us the following information. First, they give us a clear visual representation of the model. This allows us to see the shape of the molecule and the way the atoms are bonded together, meaning which atoms are bonded to which. There are many different ways that you can create a molecular model, but some examples are drawings, paintings, computer renderings, and even three-dimensional models, which could be made using really any sort of material that can be formed into the components of a model. For our purposes, you will be creating two different molecular models throughout the following lessons. You will be creating marshmallow molecules using marshmallows and toothpicks, and you will also be creating your own artistic, abstract representation of a model using paint and paper. Here are some examples of some relatively small, simple, non-complex molecules. As we can see the shape of the compound, we can also see which atoms are bonded to which, and we can see the type and the number of atoms that are present. Regardless of the complexity or the size of the molecule, the components of a molecular model are always the same, and there are only two. First, we have circles to represent each atom. Some things to keep in mind when creating your molecular model are that each circle represents one atom of a certain element. Each circle should be labeled with the element symbol or color-coded in some way to identify the type of element that circle represents. Another thing to keep in mind is that the size of the circles should represent the relative size of the atoms of the element. Let me give you an example. Here I have two atoms from a molecular modeling kit that I have. Here I have a red sphere that is meant to represent oxygen. In the color coding, it is noted that red represents oxygen. Here I have a white circle which represents hydrogen. It is also reflected in the color coding in the kit that white represents hydrogen. Now, if I were to look at them relative to one another, I can see that the hydrogen sphere is much smaller than the oxygen. That is to represent the fact that hydrogen is a smaller atom than oxygen. Anytime you are modeling, you should keep that in mind and represent relatively the sizes of the individual elements. The second component to a molecular model is the lines that represent the chemical bonds. All atoms in the model should be connected to the atoms that they are connected to in the compound, represented by one line. In a drawing, that would simply be a line, and we can see here in my molecular modeling kit, it is a plastic connector. Again, the lines that connect represent the chemical bonds that hold together the molecule. Now, a friendly rule to keep in mind when actually trying to create your own molecular models is the cnoh model. You can create a mnemonic device in your head to help you remember the order. I like to say, candy is not overly healthy, to help me remember the order. The cnoh rule stands for carbon, nitrogen, oxygen, and hydrogen. And it can be used to help us determine how atoms can bond together within a molecule. Based on the subatomic structure, which is the configuration of electrons, which you'll learn about in high school, atoms of each element on the periodic table can only form a specific number of bonds. The cnoh rule is simply an easy way to help us remember how many bonds each of these types of elements is able to form. cnoh goes in order from 4, 3, 2 to 1. It tells us that carbon, starting at number 4, can form 4 bonds. If we look at this example here from my modeling kit, as well as on the screen, you can see that any one carbon atom is able to form 4 bonds. It can form no more than 4 bonds. Nitrogen, which is listed next in the cnoh rule, is 3. Nitrogen atoms are able to form 3 bonds each, no more. Oxygen, which comes next, is able to form 2 bonds. And finally, hydrogen, our friendly atomic number 1, is only able to form 1 bond. So this gives you an example of both O and H. My oxygen is able to form 2 bonds, but each hydrogen is only able to form 1. So in steps to modeling a molecule going from chemical formula to a complete model is to start by identifying and counting the types and numbers of each atom present in the molecule. We learned how to do this in our reading chemical formulas lesson. If you need a refresher, please go back and watch that video. Once you know the type and number of atoms that are present in your molecule, next step, once you've identified the type and number of atoms present, is to use the cnoh rule to determine the shape of the molecule. Simply, we want to find out how many bonds each type of element is able to form and use that to create the shape of our molecule, remembering that carbon can form 4 bonds, nitrogen can form 3, oxygen can form 2, and hydrogen can only form a single bond. You then, simply using whichever materials or medium you are using in that example, create the model of your molecule, following the rules as we discussed in the lesson.